Imagine a machine so powerful it can smash particles together at energies greater than those inside stars. A machine buried 17 miles under the fields of Switzerland, so vast it straddles national borders. This is the Large Hadron Collider at CERN, and according to some scientists, and plenty of conspiracy theorists, its latest data is beginning to whisper a terrifying possibility: hidden forces, parallel realities, even portals to other dimensions. Sound like science fiction? Stay with me. Because what you're about to hear isn't just clickbait. It's a chain of real experiments, real anomalies, and real data that has researchers scratching their heads. And when artificial intelligence got involved, things got even stranger. For years, conspiracy forums have speculated that CERN's particle collisions could accidentally create black holes or open gateways to other dimensions. While physicists laugh this off as exaggeration, the truth is subtler and weirder. The Large Hadron Collider really does probe energies we've never reached on Earth before. Whenever we push into unknown territory, nature sometimes answers with surprises. Let's start in a place you might not expect, not CERN, but Fermilab in the United States. Here, physicists were studying muons, heavy cousins of electrons, and found something odd. Muons behave like tiny spinning tops. According to the standard model of particle physics, their wobble in a magnetic field should be perfectly predictable. But when scientists measured it, the wobble was off. Not by much, just a few parts per billion. But in the ultra-precise world of particle physics, that's enough to upend decades of theory. This anomaly, called the MON-G2 result, suggests something unseen is tugging on those muons. New particles? Hidden forces? Maybe even interactions with a parallel sector of reality we can't directly observe. Now jump back to CERN. Inside one of the LHC's detectors, the LHC-B experiment studies how particles called B mesons decay. In theory, these decays should follow well-known rules. But the data says otherwise. Dr. Matish Patel of Imperial College London called these results tantalizing hints of new physics beyond our current understanding. Translation: something big might be hiding in the math. And here's where the story leaps from the subatomic to the planetary. NASA satellites monitoring Earth's magnetosphere, the invisible bubble of magnetic field protecting our planet, have recorded mysterious spikes. These disturbances don't match solar storms, cosmic rays, or known space weather patterns. But they do line up, eerily well, with CERN's highest energy collision runs. Every time the collider smashes particles at record speeds, space itself seems to twitch, as if something 17 miles underground is brushing the edge of our cosmic bubble. And here's the problem. Sometimes the AI flags events as interesting when scientists can't see anything special. To the human eye, it's just random data. To the AI, it's a clear pattern. What if it's not just random noise? What if these AIs are glimpsing the mathematical fingerprints of another universe bleeding through into ours, structures our brains simply aren't built to notice? Meanwhile, on the other side of the world, another team was making headlines. Google's quantum computing researchers managed to simulate a tiny wormhole using qubits. It wasn't a literal hole in spacetime, but a quantum system whose behavior mimicked one. Information passed between 2 points as though through a shortcut in spacetime. If quantum systems can mimic wormholes, could high-energy particle collisions at CERN create similar effects, not just simulations, but real microscopic shortcuts? The math of quantum gravity suggests spacetime itself might emerge from quantum entanglement. If that's true, then manipulating entanglement at high energies could tug on the fabric of reality in ways we're only beginning to imagine. Skeptics will say, none of this proves anything. And they're right. We're dealing with small anomalies, complicated experiments, and oceans of data. But history shows that tiny deviations often open the biggest doors. When astronomers noticed the orbit of Mercury was slightly off, it eventually led to Einstein's general relativity. When physicists found beta decays weren't conserving energy, it led to the discovery of the neutrino. In science, a wobble here and a missing particle there can rewrite entire textboard. The difference now is scale. In the past, a single anomaly might lead to a breakthrough after decades. Today, AIs trained on CERN's data can scan billions of events and cross-correlate them with cosmic observations in real time. If reality really does have hidden layers, parallel sectors, extra dimensions, exotic forces, then the first hints might appear not as spectacular events but as subtle patterns only an algorithm can detect. And that's exactly what's happening. The algorithms are flagging ghost signatures they can't explain. Think about this: on the smallest scales, quantum particles can tunnel through barriers as if they aren't there. On the largest scales, black holes may connect distant regions of spacetime. Between those extremes sits the LHC, colliding particles at unprecedented energies, with AIs scanning the debris for hidden patterns. If there really are portals, parallel universes, or hidden forces, this is where we'll find them, not in a flash of light, but in the math, the anomalies, the AI's quiet alert. Right now it's speculation. But so was the Higgs boson once. So were gravitational waves. So was quantum teleportation. The next great revolution in physics might not be building a bigger collider. It might be building smarter tools to understand the colliders we already have, and daring to ask whether reality is bigger than we think. So the next time you hear about CERN smashing particles together, don't just think about protons and detectors. Think about hidden forces tugging on muons. Think about strange decays, magnetosphere spikes, and AI whispering about patterns in the noise. Because somewhere in that noise, there just might be the first glimpse of another universe. Thank you for watching my channel.